Bismillahirrahmanirrahim. In the last lecture, we were talking about an example that if let n be an integer such that n square is a multiple of 3, then n is also a multiple of 3, and we prove that by using a different um, proof technique by contradiction. You can say we have some few more examples, and I'm gonna refresh that information and then the way we were trying to prove that. So, and for that, I want to prove something more. That is, we have a we have to prove no real number has a square equal to 1, minus 1 actually. And to prove this, what can we do? So we can, by contradiction, we can say that suppose the statement is false, which means there is a number there is a real number say x such that x square is minus 1. However, it is a general fact about real numbers that square of any real number is greater than or equal to 0. We actually were saying this x square is greater than or equal to 0, which implies that minus 1 is greater than or equal to 0, and this is a contradiction. This is a contradiction. Hence, this statement is true. Right. We have another example which says that we need to prove under root 2 plus under root 6 is less than under root 5. Now, you'll also learn what is a non-proof actually. So let me start by giving a non-proof. So let's say, let me start by giving a non-proof. So we can say that under root 2 plus under root 6 is less than under root 5, then, or implies, under root 2 plus under root 6 square is less than, sorry, this is 15. Yeah, less than 15. Then 8 plus 2 under root 2, not 2, but 12. Under root 2 multiplied under root 6 is 12. Under root 12 is less than 15. Then 2 under root 2 is less than 7. Then 48 is less than 49. Now the last statement is true. So why is this not a proof? Okay, because the implication is going the wrong way. This implication is going the wrong way. We have shown that if P is the statement we want to prove, so we have previously we show that if P is the statement we want to prove and Q is the statement, Q is the statement that (48) is less than 49, then P implies Q. But this tells us nothing about the truth or otherwise of P. This tells us nothing. So let's say this statement is P, and we have showed that this is true, and which is Q. But if P implies Q, but Q is not telling us anything, so this is not a proof. A tuning change to the above false proof gives a correct proof by contradiction. So we start by saying that assume the result is false, which is assume 2 plus under root 6 is greater than or equal to under root 15. Previously it was less than only. Then under root 2 plus under root 16 is greater than or equal to under root 15, and then we can write under root 2 plus under root 6 square is greater than or equal to 15, and we can write 8 plus 2 under root 12 is greater than or equal to 15, and then we can write, if you just subtract this 8 from 15, you will get, sorry, there should be then 2 under root 12 is greater than or equal to 7, and we can write 48 is greater than or equal to 49. Now, which is a contradiction. So you can write which is a contradiction. Hence, we have proved that the statement under root 2 plus under root 6 is less than under root 50. The other method of proof we shall discuss is actually a way of proving statements are false. In other words, disproving them. And that we can do disproving them. So we call the method disproof by counterexample. It is best. So let's say we have a different method now, which is disproof by counter examples. And let's explain this by the example. We have two statements. A, all men are Chinese. No offense to Chinese, but just B, every positive integer, the positive integer is equal to the sum of two integer squares. Well, now, as a reader of these statements, you must have this idea in your mind that these statements are false. How to show that? Now, first, we disprove. To disprove A, we need to prove the negation. We need to prove the negation. So let's say we start saying that we want to disprove these. So to disprove A, we need to prove negation. This is also a way of proving. And the negation for A is what? Not all men are Chinese. Or we can also say there exists a man who is not Chinese. Right? And these two statements are negation of the statement A. And this can be done by just identifying one man which is not just Chinese. And this man will then be a counter example to statement A. And so you can say we can find one such man, and this will be a counter example to this, to the statement A, and proof to a counter example to statement A. Yeah. And because the point here is to disprove A. We just not need to find all the man. We just need to produce a single counter example. So to prove by count, so disprove by counter example is actually saying that you need to assume the negation for the statement and then just produced something related to that negation, and that will prove the statement. So the point is to disprove A, and to do that we just need to provide a single counter example. So we just need to provide a single counter example. Right. Likewise, to disprove B, we also need to provide, we just provide a counter example, and that is a positive integer, a positive integer that is not equal to the sum of two squares. So you can say the number 3 fits the bill nicely. So 3 is a number which is not equal to the square of n square plus m square, where n comma m belongs to the positive integers. Yeah, because the statement, so not the positive integers but the integers. Yeah. So this is the way to, this is another way to prove. So there were, so the first one was, this is the second one, proof by contradiction. The first one could be by simply proving the statement. And then there was a way, so this was the way in previous lecture, part 2, where we have proved the statement, whatever the statement was, we just assume the statement and then prove it. By contradiction, assume the contradiction and then prove it. Then we have this way, this proof by counter example. So just produce a single counter example for the negation, or like, so this method we use mostly in those cases which we have a doubt, or like we know that they are not true. And sometimes if we don't know about the proof, we try to find out the counter example. And then if we don't find the counter example, then we also uh, go for the statement to be true. This is also also a way of dealing with the proofs. Okay. Now, in the next lecture, we need to learn about the quantifiers, and I'm going to talk about in the next lecture. Thank you.